Hi! In this optional lesson, you will learn a bit about modern distributed systems. And we will start with some interesting inner workings of online storage services which you probably use, such as Dropbox, Google Drive and Yandex.Disk. Have you ever wondered how a very big file of tens or hundreds of megabytes can be uploaded almost instantly to your Dropbox account? Or maybe you are interested how Dropbox, Google Drive and Yandex.Disk save petabytes of storage space using the ideas from this module on hash tables and hash functions. Or maybe you are interested in distributed systems and distributed storage in general. Then this lecture is for you. So, services like Dropbox and Google Drive use exabytes of storage to store data of millions and millions of users worldwide. And there is a very simple idea on how to actually save some of that space and save some of the costs. So it sometimes happens that users upload the same files. So the first user liked a video with a cat and uploaded it to his Dropbox account just to save it and to show his friends. And then another user also loved this video file. He may have called it a different way, but still uploaded it to his Dropbox account, the exactly same video. And then another user also uploaded this video because this was a viral video and many people liked it, and some of them even decided to upload it to their user accounts in Dropbox. And then what we can do on the level of the whole Dropbox service is, instead of storing all 3 copies of the same video, just store 1 copy and have links from the user's files to this actual physical stored file. And then we've just saved 66% of the storage space because we basically reduced it 3 times. And if you have some large videos which are also very popular, that you can save this way a significant portion of the storage space which all the users collectively use in Dropbox to store their files. So the question is how to actually implement that. So when you do a new file upload, you need to determine whether there is already the same file in the system or not. And if there is, you just ignore the upload and set a link to the already stored file in the user's account instead of a real file. So there are a few ways to do that, and we'll start with a really simple one. Naive comparison. You take the new file that user wants to upload, you actually upload it to a temporary storage, then you go through all the stored files and you compare the new file with each of the stored files byte by byte. And if there is exactly the same file, you store a link to this file instead of the new file that user wants to upload. So there are a few drawbacks of this approach. First, you have to first upload the file anyway, so you won't see this miraculous instant upload time of large files with hundreds of megabytes. And second is to compare a file of size S with n other files. It takes time proportional to product of n and s, and that can be huge because the number of files in Dropbox or Google Drive is probably on the order of hundreds of billions or even trillions, and files uploaded are often also very large, like gigabytes. And also, if we use this strategy, then as n grows, as service for online storage grows, the total running time of all uploads will grow as n squared, because each new upload is big O of n, and it's longer and longer and longer as the number of files increases. So this approach won't work long term anyway. So what can we do? First, the idea is, instead of comparing the files themselves, try to compare hashes. As in the Rabin-Karp's algorithm, compare hashes of the files first. If the hashes are different, then the files are definitely different. And if there is a file with the same hash, then upload this new file that the user wants to upload to his account and compare the new file with the old file with the same hash directly byte by byte. Still, there are problems with this approach. First, there can be collisions, so we cannot just say that if 2 files have the same hash value, then they are equal and we don't need to store the new file. Sometimes different files can have the same hash value and we still have to compare the 2 files. And also we still have to upload the file to compare directly even if the same file is already stored. And we still have to compare with all n already stored files. So what can we do? Another idea is we can use several hash functions. If we have two equal files, even if we compute 5 different hash functions, their values on these two files will be the same. So the idea is choose several different hash functions independently. For example, take functions from polynomial family with different multiplier x or with different prime numbers p, and then compute all the hashes for each file. And if there is a file which is already stored and has all the same hash values, then the new file is probably the same as the file already stored. And in this case, we might want to not even upload the new file at all and save the time and make the upload seem immediate. And to do that, we need to just compute hashes locally before upload and only send through the network, which can be slow, the values of the hash functions, which are much less in terms of space than the initial huge file. So we compute the hash values locally, we send those 3 or 5 hash values over the network to the service. They are compared to the hash values of the files already stored, and if there is a file with the same set of hash values, we don't upload our new file. And this is how the instant upload works sometimes, when you try to upload the file which is already stored by someone else. Well, of course, there is a problem with collisions, because collisions can happen even if you have several different hash functions. Still, there can be 2 different files which have the same set of hash values even for several hash functions. And there are even algorithms which on purpose find 2 different files which have the same value of a given hash function, if you know for which hash function you are trying to find a collision. However, for hash functions used in practice, collisions are extremely rare and hard to find. And if you use more than 1 hash function, if you use 3 or even 5, then you probably won't see a collision in a lifetime. So this is actually done in practice. You compute several different hash functions which nobody knows, and then it is so hard to find 2 files for which all the hash functions have the same values that a new file is considered to be equal to the old stored file if all the hash values coincide with the hash values of the file already stored. So we still have an unsolved problem that we need to do big O of n comparisons with all the already stored files. So how can we solve this problem? Well, we can first pre-compute hashes, because when a file is submitted for upload, hash values for this file are computed anyway. So we can store the addresses of the files which are already stored in the service in a hash table, and along with the addresses of the files, we'll store those hash values for each file. So we pre-compute them and store them. And when we need to search for a new file, we actually only need to search in the hash table, and we need only the values of the hash functions on this file to search for it. We don't need to provide the file itself. So we search for the hash values in the hash table, and if we find some file stored in this hash table with the same set of hash values, then we know that there is already such file stored in the system. So the final solution is the following. We choose from 3 to 5 different good hash functions for which it is hard to find collisions, so that we don't see collisions in practice. We store the addresses of the files and the hashes of those files in a hash table, and before we upload a new file, we compute the hashes locally, we send them over the network to the service, we check whether there is a file in a hash table with the same hash values, and if all the hashes for some stored file coincide with the hashes of the new file, then the search is successful. And in this case, we don't even upload the file, we just store a link in the user account to the existing already stored file. So this how we can do instant upload to Dropbox or Google Drive or Yandex Disk, and this is actually how they save a lot of space, probably petabytes of space in their services. However, there are more problems to this, because it turns out that billions of files are uploaded daily, for example, into Dropbox, and it means that probably around trillions are already stored there, and that is just too big for a simple hash table on one computer. And also, millions of users upload simultaneously their files, and so this is also too many requests for a single hash table. And so you need some more sophisticated solution to cope with those two things. And see our next lecture to understand how that problem is solved.